Hi, my name is Sandesh Dhagle and I am a Business Development Manager at VMware. Today I'm going to talk about the RAN Intelligence Controller or RIC. To understand RIC, let's first look at the ORAN architecture's four key dimensions of disaggregation. First one is the radio disaggregation with the open front hall that enables multi-vendor compatibility between the RU and the DU. The second one is the compute disaggregation with cloud native RAN software workloads running on top of commercial off-the-shelf hardware. The third is the management plane disaggregation with service management and orchestration layer. And the fourth one is the control plane disaggregation that is referred as RAN Intelligence Controller or RIC. The RAN Intelligence Controller is a critical component of ORAN architecture, which is responsible for controlling and optimizing the underlying RAN functions and infrastructure. So why do we need a RIC in the first place? To understand that, let's look at the 5G specifications of control and user plane separation, or use cases such as ultra-low latency or network slicing, which requires a combination of RAN virtualization and SDN capabilities to configure, control, and optimize the RAN infrastructure even at the edge. Hence, an element like RIC is required to accomplish this. RIC also helps to abstract the complexities of open and multi-vendor RAN through programmability and intelligence, as well as brings agility and innovation to the RAN ecosystem. Now, let's look at the ORAN reference architecture in detail to understand the two different RIC components. First one is a non-real-time RIC, or also known as the non-RT RIC, and second is a near real-time RIC or the near RT RIC. The non-real-time RIC or the non-RT RIC supports tasks that typically requires latency of more than 1 second. This includes configuration management, device management, fault management, performance management, and lifecycle management for all the network elements in the RAN network. The primary goal of a non-real-time RIC is to support intelligent RAN optimization by providing policy-based guidance and management, as well as an enrichment information to the near real-time RIC functions so that the RAN can be optimized. The non-RT RIC leverages the service management and orchestration services such as data collection and provisioning to run data analytics and use AI ML capabilities to determine the RAN optimization. The near real-time RIC supports tasks that requires latency in the range of 10 milliseconds to 1 second, such as mobility management, radio resource management, traffic steering, and advanced SON capabilities. The primary goal of near real-time RIC is to improve network resource utilization and end-user experience. Both near real-time and non-real-time RIC are implemented as microservices-based platforms and provide a cloud-native platform to host apps. This provides the possibilities for CSPs and developer community at large to build and host apps to maximize the RAN potential. The near real-time RIC can host X apps for improving the RAN utilization and end-user experience, whereas the non-real-time RIC can host R apps to utilize AI/ML capabilities and provide policies for the underlying RAN and the near real-time RIC. Both non-real-time and near real-time RIC exposes APIs that can be utilized to interact with the RAN infrastructure and provide programmable interface to the RAN network. And this enables a vast array of new services and hence new revenue streams for the CSPs that were previously not possible. It enables the RAN network capabilities to be programmed for the use cases rather than the current limitation of network capabilities based RAN use cases. We at VMware have both the near real-time RIC and non-real-time RIC, and to provide the CSPs and the developer communities with potential to innovate, we also have RIC SDKs available to create both the X apps and the R apps. This approach will foster innovation in the RIC space and make RIC's vision of best-in-breed RAN a reality. So to conclude, the RIC is thus a key central piece in the overall architecture that drives flexibility and agility of service deployment through end-to-end closed-loop automation and provides programmability to the RAN. It is therefore a key element for the success of interoperable multi-vendor and fully open and disaggregated RAN ecosystem. And it is vital for the implementation of new use cases such as end-to-end network slicing and exploit new revenue streams by enabling the networks to run as a service. Thank you.